we go. All right. That was part 1, number 10. So, which one would you like to do next?
1, 9.
Part 1, number 9. Part 1, number 9, it says, if a point with coordinates 3/5, y is on the unit circle, find the value of y. Easiest way to go about a question like this is to use the big idea on your unit circle that you know that points on your unit circle are cos theta, sine theta. So from this, we know that cos of theta is equal to 3/5. If you know that cos of theta is equal to 3/5, you can draw a triangle. The triangle would be where? Either in quadrant 1 or in quadrant 4, because cos is positive in quadrant 1 and quadrant 4. Which kind of makes sense, because if I draw a unit circle right here, and I know that the x coordinate was 3/5, it could have either been up there, or it could have been down there. Because that would be an x coordinate of 3/5 on my unit circle. But what we do when we draw our triangle is we're not drawing the triangle on the little unit circle. I would draw the triangle, label my reference angle, and cos is adjacent over hypotenuse. I do a squared plus b squared equals c squared, and find out this side is 4. And then your y coordinate is sine. Sine is opposite over hypotenuse, so you're going to get 4/5. But here it would be positive, and here it'd be negative. So there's our answer for the y coordinates on our graph. Which we're not using this triangle, because on this triangle this is 1 and this length would be 3/5, and you have to work with fractions. It's better just to draw the bigger triangle. Makes a squared plus b squared equals c squared easier.
Is that okay that use the formula to
Yeah.
find it?
You could also use the equation of the circle, or sine squared plus cos squared equals 1. That will work as well. I just find if you draw the triangle, then you're not dealing with any fractions here. You still have to work with fractions. Not hard, but less mistakes without fractions. Okay. Part 2. Number 6. Solve sine squared x minus 3 cos x equals 3. And they even give you a hint. You have to use the big idea. Now the big idea of sine squared x plus cos squared x equals 1 can be rearranged so that either sine squared x or cos squared x is by itself. In this case, I'm going to rearrange it so that sine squared x is by itself. And the reason for that is the black equation that we're trying to solve has a cos and it has a sine. You can't do any factoring, you can't do any solving, because you have 2 different trig functions. However, if I rewrite this, but instead of the sine squared,
1 minus cosine.
I write 1 minus cosine squared of x. Now I have only cos. And it's a quadratic equation. So maybe we can factor it, maybe we have to use the quadratic formula. Before we can determine that, I'll make one side equal to 0. I'm going to move everything to the right side because I like it when whatever I have squared is positive. So if I move the cos squared to that side, it'll be positive. The 3 cos to this side will be positive. The 1 to this side will still give me plus 2. And what's really nice is this factors. Cos x plus 2 cos x plus 1. So we can solve, and we find out that cos x can either equal -2 or cos x can equal -1. -1 is on our pie plate. That's at pi. -2
It's not possible.
is not possible. Because anytime sine or cos has a fraction, I can make that over 1, where the fraction is bigger than 1, you can't have the opposite or adjacent side bigger than the hypotenuse. So on this side, we would just write not possible. Now the last thing I'm going to do is look at the domain. It is between 0 and 2 pi. Oh, don't have to change any answers. That makes me happy. We're all done. So this is a very typical kind of question that's going to happen more and more, where you have two different trig functions and you have to solve it with those two different trig functions. In fact, a lot of the rest of unit chapter 7 will deal with things like that. Okay. Yes.
What happens if we say domain is between 0 and 3 pi over 2?
So if the domain was between 0 and 3 pi over 2,
Yes.
so that would check from here up to here. That's where you would check.
Yes.
Still would only have pi as your answer. Okay? And because quadrant 4, there was no answers in quadrant 4, that wouldn't affect it in this case. But it is something you have to check the domain at the end anyways, to make sure that your answer fits within the domain that was given. All right. Next question. Yes. Part 3? Part 2, number 7. Tan squared x equals √3 over 3 tan x. And this one is a general solution question because it says XER. Okay? So, general solution says solve between 0 and 2 pi like normal first. Then you're going to add 2k pi to each of your answers. So we need to solve this between 0 and 2 pi first. First of all, quadratic equation. I can't just square root because I have another tan over here. So how do we solve quadratic equations? We make one side equal to 0. So I'll subtract the √3 over 3 tan x on both sides. So one side is equal to 0. Can we factor this? Yes. There is a common factor of tan in both of them. So you can take that common factor out. Bracket equals 0. And slide this over. And so now you've changed it to multiplying. So we can split it here. Either tan x is equal to 0 or tan x is equal to √3 over 3. Both of those values on your pie plate. This would be 0 pi and 2 pi. This would be pi over 6 in quadrant 1 and 7 pi over 6 in quadrant 3. Now to write your general solution, okay, you could take all 5 of those and write 2 plus 2k pi. I will not deduct any marks for you writing more than you need to. But you could also, yeah, so I'm going to do it, this, just so you can see it. Does it take very long to write them all? No. Like, oh, look at that. Look at that. Oh, that was good. You thought I was writing them 11. that I was. It's a 7. So that was a nice recovery. That's probably the best looking 7 you've seen for quite some time. So it doesn't take long to do that. Or if you wanted to make it shorter, check this out. 0 and 2 pi are already at the same place. So I could have just taken the 2 pi out because it's covered in the 0 one. This is redundant. This wasn't, like, and you put a line right through it right now. It wasn't even necessary in the first one. The other thing to notice is we have 0, then pi, then 2 pi, then 3 pi, then 4 pi, then 5 pi. I'm going to have all the numbers of pi. I could actually combine the first 3 to just be k pi. That would be shorter. I could also combine pi over 6 and 7 pi over 6 because they're also halfway around. So I could combine those ones if I wanted to by starting with pi over 6 and saying, oh, just keep going halfway around plus k pi. And this is a shorter answer, means exactly the same thing as the first answer. I don't know how I wrote it. How did I write in the answer key? Did I have the long, oh, I had the long way. I had a mix of the long way and the short way. I made the k pi the short way, but I kept these ones in the long way. But just helps explain where those things come from. Now I left some space here because I am going to show you the number one temptation that people do in this question. They're like, ugh. They start and go, I don't like all those 10s. I'm going to get rid of one by dividing both sides by 10. Okay? If I divide both sides by 10, I just get tan x. I get root 3 over 3. I feel good because that's on my pi plate. And I would get those answers and only those answers. You would miss all of these answers. Why does dividing by 10 on both sides cause a problem? Because one of the solutions is 10 is equal to 0. So when you divide both sides by 10, you're technically, possibly, dividing by 0 without knowing it. And that's why this technique loses you half of the answers. So if you're tempted to divide, factor instead. Because factoring is like dividing, but it keeps it there. And then you won't miss out on any solutions. So this will be the number one temptation that will come up, is people will divide instead of factor. That always is really easy for me to mark. It's a 1-mark deduction, because you're missing the answers on that side. So if you're like, I didn't want full marks anyways, I'm going to use that technique. Looks like it's worth it. It's shorter. Don't have to write as much. Definitely worth the 1-mark deduction. Perfect. Dear Mr. Jarrett, I know how to do this correctly, but this is shorter, and it's only 1 mark off, so I'll do it. Yes?
We do part 2, 11.
Part 2, number 11. Part 2, number 11 says, solve for theta, sine 2 theta equals root 3 over 2. Okay. Do we remember what kind of question this was? What did we call it when we had a 2 theta or 3 theta inside? Gave it a name, yes. I called it a multi-revolution question. So this is a multi-revolution question. And there's actually, in the answer key, I gave the answers in 2 different ways. One way is the way that I taught you in class, and the second way the answer is there, I'll show you today in case you like that even better. Okay? In the ones that we always had in class, we always had solve, and then it first said from 0 to 2 pi, and then said the general solution. This one skipped the, say the answers between 0 and 2 pi, and just said, find the general solution. So that's the reason why there's two different answers, because it depends how you logically went about thinking this question. If we solved it how we did in class. In class, we first solved between 0 and 2 pi, then all the answers you get, add 2k pi, that's how you do your general solution. But since it's a multi-revolution question, if 1 theta is between 0 and 2 pi, then 2 thetas would be between 0 and 4 pi, which is twice around the circle, hence the name multi-revolution question. For a multi-revolution question, once you found the domain for 2 theta, you then solved root 3 over 2 on our pi plate? Yes. Quadrants 1 and 2, because it's positive. What family? That's your pi over 3 family. So in quadrant 1, pi over 3. In quadrant 2, 2 pi over 3. But that's only once around the circle. The second time around the circle, this one would be coterminal with this one. How do we find something that's coterminal? We could add 2 pi. But if I'm adding 2 pi, I need a common denominator. So can you see that that would be 6 pi over 3? So 1 pi over 3 plus 6 pi over 3 will tell me 7 pi over 3. And this one plus 6 pi over 3, 8 pi over 3. Then to solve for theta, we have to divide everything by 2, which is like multiplying by a half pi over 6. This one will divide by 2, would reduce to pi over 3, then 7 pi over 6. And I could have reduced that one, or you can leave it as 8 pi over 6. Either is fine. I think in the answer, did I reduce it to 4 pi over 3? I did. So, if you first solve between 0 and 2 pi, and get those 4 answers, then the general solution would be x theta equals pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3, plus 2k pi, plus 2k pi, plus 2k pi, plus 2k pi. Okay, it's an integer. That's how we did it in class. We always solve between 0 and 2 pi first for a general solution, and then all of the answers that you have between 0 and 2 pi, you write all the coterminal angles by adding plus 2k pi. In our notes, we never had a question like this one that just said directly find the general solution. So this is why there is a second, I'm going to say more elegant, way of solving this. Okay? The more elegant way of solving, and this will only work if it's a general solution only. Is first find the general solution for, and I'll put it in brackets just like in our notes when we, whatever's inside. So I'm going to find the general solution for 2 theta. If this was just a regular general solution question, you would solve between 0 and 2 pi, which would be your pi over 3 family, pi over 3 and 2 pi over 3. So we'll write it like this. 2 theta would equal pi over 3 and 2 pi over 3 plus 2k pi plus 2k pi for k is an integer. That would be the general solution for 2 theta. What do you think you have to do to get theta by itself? Divide by 2. Now, if I take the first solution and divide by 2, instead of pi over 3, I would have pi over 6, and instead of plus 2k pi, divide that by 2, and I just have plus k pi. And 2 pi over 3 divided by, well, technically, that would be just pi over 3. And divide that by 2 would be plus k pi. So this is a little bit more elegant. And if we think about these answers, pi over 6 and 7 pi over 6, where are they? They're like here and here, halfway around. So you could have just done pi over 6 plus k pi would include both of those. And where are pi over 3 and 4 pi over 3? Halfway around. So you could have just done pi over 3 plus k pi. So this is more elegant and a little bit easier because you never have to spend the time going multi-revolution. Question? Yeah, that's a mistake. It should be divided by 2. Thank you for noting. I think I was thinking it was a 3 theta question when I copied that answer. So there's a mistake because it should be over 2 in the answer key, not over 3 for the shortcut method. There should be little 2's on the bottom to make them k pi. Can I do this? Yes. Yeah. Any other ones? Part 2, number 2. I'll go back. We'll start it in a second. We'll let everybody finish writing this down that wants to. All done? Okay. Part 2, number 2. We have sine squared 45 degrees plus cos squared 60 degrees equals what? Question. We have this sure looks like a big idea. And our big idea says sine squared x plus cos squared x equals 1. Can we just say this is equal to 1? No, because this only works. Oh, this would be so nice if you could. But this only works if the x is the same. So I think there's one where there's, yeah, number 4 says cos squared of 112 degrees plus sine squared of 112 degrees. That one's easy. That one you can use this idea and say it's 1. But this one, the angles are different. So we have to figure them out each individually. Put 45 and 60 on your pie plate. And remember that squared means multiply by itself. I mean, I could write this out. This is the same thing, right? That would mean the same thing. Because when it's squared, it means multiply by itself. And so, what is sine of 45? It's root 2 over 2. And you're going to have 2 of them, so you can either write them out twice or just write squared. Probably, since this is squared, you would not take all this extra time to write this out, but just say, I know sine of 45 is root 2 over 2, so sine squared of 45 would be root 2 over 2 squared. And cos of 60 degrees, close. Is it a half? Yes, it is a half. Woo. Very close. Almost exactly. actually exact. Cos of 60 degrees is a half, so cos squared of 60 degrees will be a half times a half. Now, squaring this, root 2 times root 2 is 2, 2 times 2 is 4, plus 1 times 1 is 1, 2 times 2 is 4. 1/4 plus 2/4 will be 3/4. And you'll notice once you understand part 1, you can do part 3. Once you understand part 2, you can do part 4. Once you understand part 1 and part 3, you should be able to do part 5, which is the first part of your quiz. And once you understand part 2 and part 4, you should be able to do part 6, which is the second part of your quiz. Your quiz has 2 parts, a front page and a back page.
Non-calculator.
Yes, non-calculator and calculator just like this.
Are we using this or not?
Sure. No. Not yet. Not yet. After we do our test, you're allowed to use your unit circle for the rest of Chapter 7 and for Chapter 7. Yes, when you get your quiz, I'll give you a little tiny blank little unit circle. You can fill in quadrant 1 quickly and then use that for your whole quiz. Any other questions? There's a calculator and a non-calculator part. Part 4, number 9. Ooh, this is a good question. When is sine theta bigger than cos theta? And I, again, find for this one, the best way to solve it is using a graph. From 0 to 2 pi. So here's 2 pi, here's pi, here's my axes family. Both sine and cosine have maximums of 1 and -1. I'm going to draw sine in green. It starts in the middle going up. And this question says only on the interval from 0 to 2 pi, so I don't have to add arrowheads. I'm going to draw cos in blue. Cos starts at a maximum. Okay. And this question is asking, when is sine bigger than cos? I'm going to highlight that in yellow. The sine is the green graph. So if sine is bigger than cos, the green graph would have to be above the blue graph. At the beginning, it's not. But here, it is until here. So we need to find out, what is this starting point? What is this ending point? Because it's going to be an interval. And how did you figure out the pi over 4?
Guess.
You guessed it. Oh, that's a good guess. That's better than, I looked at the answer sheet. That would also be a correct method of getting it right. Okay? Why is this pi over 4? Because if the two graphs intersect, that's where the two graphs are the same. If you think about your unit circle, are your x coordinates and y coordinates ever the same? Yes, 45 degrees. They're both root 2 over 2. So it's going to go from pi over 4. Then they're going to be the same again where? Pi over 4 family again, but which quadrant? Quadrant 3. So it'll have to be 5 pi over 4. Look in detail. Does this question, it just says greater than. So we would use round brackets, because at pi over 4 they are equal, but there is no equal sign there. It's just greater than. So you can't include pi over 4. You can't include 5 pi. Why Why is the graph the best way? I find that the most common method of getting it mostly right or half right is just using the CAS rule. And students say, oh, it has to be quadrant 2 because sine is positive, cos is negative. That's true. But quadrant 2 would only include from here to here. And you would miss this little bit and this little bit. And lose one mark. Yes. You would get half of it right. You get 1 out of 2. Lose 1 mark. It's only out of half. We're good? Would you like the last 20 minutes just to keep working on this?
Yes.
And then I'll post this video. It takes a while